We're team #underwater_bubbles and we made a bubble blowing machine. First, we decided we needed to do the engineering design process. The first step of the engineering design process is ask. So we wanted to ask how to make an efficient and cost-effective bubble blowing machine using a single power source, and it needed to be within a $40 budget. It also needed to have different sizes and different rates of speeds. The next step of the engineering design process is imagine. We needed to come up with ways to get the bubble solution onto the wand. We also needed to create a wand, and so we decided to go between 3 different wands: a 3D printed wand, a bottle cap wand, and a pipe cleaner wand. We also needed to decide which power source to use. We then needed to connect the power source to a circuit board, and the circuit board was going to be connected to the wand while a fan blew to make the bubbles come out. The next step is plan. Originally, we were going to create a 3D printed wand, and we decided to go instead with a wand made of straws and bottle cap rings. We also needed a motor powered by a certain power source. At first, we wanted to do a solar panel connected to the wand by a circuit board, but instead we went with a battery power source. The circuit board needed to have a switch so the fan could have 2 different speeds, and we also used a combination of 2 snap circuit kits to make the circuit board. The next step of the design process is create. We used a snap circuit kit to connect a battery to a fan and a motor. We also made a wand out of straws and bottle cap rings, and then connected that to a circle piece of cardboard, and we used tape to connect it all. We used a transistor to separate the current into 2 different paths, and then we used a resistor on one of those paths to withhold current so it can make the fan go slower to get our different speed. We used a parallel circuit in order to reduce the current flowing through the circuit. We also used, for the bubble solution, method soap, water, and a lot of glycerin. For the improved stage, we changed the wand to a pipe cleaner wand because the bottle cap wand fell apart due to the solution interfering with the tape on the straws. We changed the motor of the fan so the fan would go faster. We used a less powerful resistor so the speed of the wand would be fast enough to blow out bubbles. We also changed the bubble solution because it had too much glycerin, which is making the bubbles too strong. And we also used a different soap in the bubble solution because Method was too weak of a soap and we needed a stronger soap, so we used Dawn. And lastly, we used a higher voltage battery so it can make the fan and the wand a more powerful speed.
So the budget for the automatic bubble blower was $40. We spent $9 on motor, $8 on glycerin, $4 on glue, $8 on batteries, and we bought a trifold poster board for $10. So our total cost was $38.51. We did have some pre-owned items. The snap kit was provided by a tool. The Dawn and Method soap we already had. Packaging tape, pipe cleaners, and plastic containers came from the engineering resource room, and we also had extra cardboard from gift packages that we've gotten. Our solution recipe consisted of 1 cup of water, 2 cups of dish soap, 40 milliliters of glycerin. And we looked online and saw that if we were to leave the solution overnight, it would produce the best results. We decided to use glycerin in our solution recipe because we learned that glycerin helps to strengthen the bubbles.
We had faced many challenges during this process. One included that our first fan was too slow to blow the bubbles. Another thing was that our first bubble solution was originally too weak, and then when we changed the solution, it became too strong due to the too much addition of glycerin. Also, our motor for the fan was too fast to catch wind. Another problem we had was our bottle cap and straw wand fell apart from the solution, impairing the tape, which made us have to create another wand. Some key information from the research was resistors were gonna be necessary for this project. With us needing to have 2 different speeds for our bubble wands, we could have 2 different resistors, each with a different strength, which allowed us to have 2 different speeds. Also, with us using motors, we had to make sure there was no chaos in the system. If we were to do this FEDD project over, we would do many things differently. We would first start the project much earlier than we actually had. We would also spend more time brainstorming and researching the different sources. We also would test the machine less because of our excessive testing led to wear and tears with the different components and broke on the last week, causing us to panic and have extra work. Some advice I would give to the freshmen doing this FEDD project next year: make sure to start the project early and do not procrastinate. Also, test the prototype early just so you have enough time to fix the problems. Also, keep an eye on the budget because we came close with $38. Sadly, our project did not place in the competition, but it was able to function for the most part. This is a video from the actual FEDD competition.